The Whirlpool Galaxy is one of the most beautiful objects in the sky. But that beauty isn't natural. It's the result of another galaxy slowly ripping it apart. Today I'm breaking down every major galaxy collision we know about, what caused them, and what they tell us about the universe, starting with the gentlest one on the list, the Whirlpool Galaxy. M51 sits about 23 million light-years away in Canes Venatici, and it holds a pretty incredible distinction. In 1845, William Parsons pointed a telescope at it and became the first person to ever resolve the spiral structure of a galaxy. Those sweeping arms have been iconic ever since. But here's the thing, they're not supposed to look like that. M51's companion, a smaller galaxy called NGC 5195, has been gravitationally interacting with it for roughly 500 million years. That interaction is directly responsible for the Whirlpool's enhanced spiral structure. NGC 5195's gravitational pull generates density waves through M51's disk, compressing gas clouds along the arms and triggering massive bursts of star formation. The bright pink regions and blue star clusters in every Hubble photo. The beauty is literally a wound. Observations have revealed faint tidal structures stretching out from the system, basically gravitational scars from repeated close encounters, and NG C5195 itself has been so warped that it's become a visibly disturbed irregular galaxy. Which is, not ideal. This is a gravitational waltz, not a car crash. But over the next several 100 million years, these two will spiral closer until they merge into a single galaxy. The pretty spiral arms will be gone forever. But if you think a slow dance sounds tame, wait until you see what happens when two galaxies smash together like actual butterflies pinned to a board. The butterfly galaxies, NGC 4567 and 4568, look completely fine. That's the problem. Sitting about 60 million light-years away in the Virgo cluster, these two spiral galaxies appear almost pristine, gently overlapping like a pair of butterfly wings touching at the tips. William Herschel first spotted them back in 1784, and honestly, at a glance, you'd think they were just two galaxies minding their own business. They are not minding their own business. Studies of neutral and molecular hydrogen across the system confirm that these two are actively merging. The highest concentration of star formation activity sits right in the overlap region. Exactly where the two galaxies are pressing. This is a collision in progress. It just doesn't look like one yet because we're catching it in the earliest phase, the calm before everything goes sideways. But here's the kicker. Even in this supposedly early stage, 3 supernovae have already been recorded in the system. Haiba SN 2004 C, a Type 1c, among them. 3 massive stellar explosions in a system that hasn't even gotten violent yet. Which is, not ideal. In roughly 500 million years, these two galaxies will fully coalesce into a single elliptical galaxy. Everything you see now, the distinct spiral arms, the butterfly shape, all of it, gone. What we're looking at is essentially the before photo of a galactic car crash. The structures are still largely intact, but gravity has already made the introductions, and there's no separating them now. But if the butterfly galaxies are the before photo, ARP 273 is what happens when things start getting dramatic. ARP 273. One of the most beautiful objects ever photographed by Hubble is actually a gravitational crime scene. ARP 273 sits 300 million light-years away in the constellation Andromeda, and it looks exactly like a rose. 2 spiral galaxies, UGC 1810, and its smaller companion UGC 1813, twisted together into something that belongs in a botanical garden, not deep space. But that elegance is hiding violence. Here's what happened. UGC 1810 is roughly 5 times more massive than its companion, and that companion didn't just graze past it. UGC 1813 dove through the disk of the larger galaxy, and the gravitational interaction dragged everything out of shape. The evidence is written all over UGC 1810's structure. That large outer arm, it's tidally stretched into a partial ring structure, a signature of a close gravitational encounter warping the spiral pattern. You don't get that from a flyby. Across the top of the larger galaxy, there's a swath of blue star clusters, intensely hot, intensely young stars, born from tidal compression during the encounter. The smaller galaxy actually started its starburst activity before the larger one did, which is exactly what models predict in equal mass interaction. The little one feels it first, but here's where it gets genuinely weird. The inner spiral arms of UGC 1810 are warped completely out of the galactic plane. One arm goes behind the central bulge and somehow emerges on the other side. How these two spiral patterns actually connect is something astronomers still don't precisely understand. A tenuous bridge of material stretches between the two galaxies across tens of thousands of light years, like a thread holding the whole crime scene together. It's beautiful. It's violent. And it's not even close to the messiest collision on this list. because the mice galaxies took tidal destruction and turned it into an art form, the mice galaxy. Most galaxy collisions are lopsided. A big one eats a small one, or a dwarf grazes a giant, but NGC4676 is something different entirely. This is two nearly identical spiral galaxies, roughly the same mass, ripping each other apart in perfect symmetry. And the result is one of the most visually striking disasters in the observable universe. Located about 300 million light-years away in Coma Berenices, the mice galaxies earned their nickname from the two long tails of stars and gas streaming out from each galaxy, looking exactly like a pair of mice running in opposite directions. Those tails aren't just simple straight streamers either. They're complex structures shaped by gravitational dynamics, curving and stretching across hundreds of thousands of light-years. A tidal catastrophe frozen in motion. Simulations place us at roughly 160 million years after the pair's close encounter, meaning we're watching the rebound phase. They've already had their first devastating pass, and now they're pulling apart, trailing wreckage behind them. The northern galaxy is absolutely lit up with young, hot blue star cluster, triggered directly by tidal forces during the encounter. You can literally trace streams of material flowing between the two galaxies. It's not subtle, but here's where it gets genuinely wild. Inside those tidal tails, clumps of young stars have formed with masses comparable to dwarf galaxies. This collision isn't just destroying two galaxies, it's building new ones from scratch. Entirely new satellite galaxies assembled from debris, like cosmic recycling on the most absurd scale imaginable. The pair will eventually merge into a single elliptical galaxy. The material in those tails will either fall back into the merged system or keep orbiting as brand new satellite galaxies around something that didn't exist. They collided. Creation from destruction, which is, kind of beautiful in a horrifying way. But if you think two identical galaxies tearing each other apart is dramatic, wait until you see what happens when two spirals fully commit to the merger. The antennae galaxies, this is the poster child. If galaxy collisions had a marketing department, the antennae galaxies would be on every brochure, every billboard, every motivational poster in the break room. NGC 4038 and NGC 4039 sit about 45 million light-years away in the constellation Corvus, making them one of the closest and youngest colliding galaxy pairs we know of. They started interacting somewhere around 600 million years ago, and they've been putting on a show ever since. The name comes from two massive tidal tails stretching hundreds of thousands of light-years outward from the galactic cores, formed by gravitational forces ripping stars, it is gas, and dust into intergalactic space. Through a ground-based telescope, they look exactly like insect antennae, which is, a charming name for something born out of unimaginable violence. But here's where it gets interesting. Nearly half of the faint objects visible in this system are young star clusters, each containing tens of thousands of stars. The brightest and most compact of these are called superstar clusters, among the most massive stellar groupings ever observed. The antennae galaxies are basically a star factory running triple overtime. Here's the kicker, though. Only about 10% of those newly formed superstar clusters will survive past 10 million years. 90% of everything being born in this spectacular collision is already doomed. Cool. That's also a thing that happened. Roughly 100 of the most massive clusters will endure long enough to become globular clusters, similar to the ancient ones orbiting the Milky Way's halo. Simulations show distinct starburst episodes tied to each close passage. Earlier encounters produce widespread star formation across the whole. But the final coalescence concentrates everything into the galactic nucleus, producing cluster masses far higher than anything an isolated galaxy could man on its own. The finale is always the loudest, and this system isn't just academically interesting, it's a preview. This is roughly what the Milky Way and Andromeda will look like billions of years from now. But if you think two spirals smashing together is dramatic, wait until you see what happens when a galaxy takes a bullet through its center. The Cartwheel Galaxy. Most galaxy collisions are messy. Glancing blows, off-center passes, awkward gravitational fumbles. But every once in a while, the universe lines up a perfect bullseye. One galaxy punches straight through the dead center of another, and the result looks exactly like someone threw a stone into a cosmic pond. ESO 350-40 sits about 500 million light-years away in the constellation Sculptor, and it used to be a completely normal spiral galaxy. Probably looked a lot like the Milky Way. Then, somewhere between 200 and 300 million years ago, a smaller companion galaxy slammed directly through its center. Not a graze, not a flyby, and straight through the middle. That collision sent a gravitational shockwave rippling outward through the entire disk, compressing gas and dust as it expanded. Two rings formed from that single impact, both radiating outward from the collision point like ripples from a dropped stone. The outer ring is absolutely with star formation. New stars ignite, massive ones detonate as supernovae, and those blast waves compress surrounding gas, triggering even more star formation. It's a self-sustaining cycle of creation and destruction rolling outward through space, but here's where it gets genuinely fascinating. When the James Webb Space Telescope turned its infrared eyes on the cartwheel, it revealed something Hubble had only hinted at. Spiraling spokes connecting the inner and outer rings, forming the galaxy's skeletal structure. These spokes are rich in hydrocarbons and silicate dust, chemically similar to the dust you'd find on Earth. Webb made the entire underlying architecture visible for the first time. Here's the thing, though. The Cartwheel Galaxy is temporary. Over the next few 100 million years, the rings will fade, and the galaxy will likely rebuild itself into a spiral. It got punched clean through its core, and it's just gonna walk it off. Which is, reassuring. But if the cartwheel got hit and kept its dignity, the next galaxy wasn't nearly as lucky. It got its entire backside ripped off. The Tadpole Galaxy. UGC 10214 committed the cardinal sin of being a perfectly normal barred spiral galaxy in the wrong place at the wrong time. Sitting around 420 million light years away in the constellation Draco, this galaxy got absolutely blindsided by a compact intruder galaxy roughly 100 million years ago. The intruder crossed directly in front of the tadpole, got caught in its gravitational pull, and was slung around behind it like a rock in a... And the result is one of the most absurdly proportioned galaxies ever, the tail. That's what everyone talks about, and for good reason. It stretches more than 280,000 light years from the main body. The entire Milky Way is about 100,000 light years across. This galaxy's tail is nearly 3 Milky Ways long, which is, not ideal if you were trying to keep a low profile. But here's the kicker. The intruder galaxy is still there. It committed the crime, and it's literally still at the scene, lurking approximately 300,000 light years behind the tadpole. You can actually see it through the foreground spiral arms, just hanging out. No remorse whatsoever. The tail itself is loaded with bright blue star clusters, some containing as many as 1 million stars each, with individual stars burning hot enough to make our sun look like a nightlight. 2 prominent clumps of young blue stars sit separated by a gap in the tail, and astronomers believe both will eventually break off and become independent dwarf galaxies. New galaxies, born from wreckage. 2 supernovae have also been observed in the system because apparently getting your entire structure ripped apart wasn't enough excitement. The poetic part is that the tadpole will eventually lose its tail. The tidal debris will either fall back into the main galaxy or drift into independent orbit. The tadpole grows up, loses its tail, becomes a regular galaxy again. Almost wholesome if you ignore the 280,000 light years of gravitational violence that caused it, but if the tadpole seems dramatic, wait until you see what happens when an entire spiral galaxy gets swallowed by an elliptical one and produces jets powerful enough to stretch over 1 million light years into space. Centaurus. This is what a galaxy looks like after it's eaten another galaxy, and the corpse is still visible. Centaurus sits approximately 13 million light years away, making it the closest large active galaxy to Earth. It was discovered in 1826 by James Dunlop observing from Australia, and at first glance it looks like a normal elliptical galaxy, but cut across the middle is this enormous band of dark dust that has zero business being there. That dust lane is the remnant of a smaller spiral galaxy that Centaurus A swallowed whole. The spiral didn't just disappear, it's still there, bisecting the host like a galactic fossil record frozen mid-digestion. The collision compressed interstellar gas, triggering intense star formation and giving the dust a distinctive, fleecy texture. Dark filaments of cold hydrogen are silhouetted against the yellow-orange glow of background stars. It looks beautiful. It's also the aftermath of total annihilation, but here's where it gets violent. The supermassive black hole at the center has a mass of approximately 55 million solar masses. That's roughly 13 times heavier than the black hole at the center of our galaxy. And it's angry. This thing produces relativistic jets moving at approximately half the speed of light. The radial lobes extend over 1 million light years. 1 million. That's a single black hole projecting energy across a distance roughly 10 times the diameter of the Milky Way itself, which is, not ideal if you're anything in the general vicinity. And then the Event Horizon Telescope pointed at it. Observations revealed the jet is brighter at its edges than at its center, a phenomenon never previously observed this clearly in any jet anywhere. A tilted disk of hot gas encircles the black hole, feeding material into the engine that powers all of this destruction. New science, coming from a galaxy that finished eating another galaxy and decided to scream about it at half the speed of light for 1 million light years in every direction. But if Centaurus A is the aftermath of a collision, there's one more we need to talk about. The one that hasn't happened yet, the one that involves us. Milk Dromeda. This is the one you've been waiting for. The one that actually involves us. And here's the thing. everything you've been told about it might be wrong. The Andromeda Galaxy is heading toward the Milky Way right now at approximately 110 kilometers per second. For decades, the story was simple. Head-on collision, roughly 4.5 billion years from now, absolutely guaranteed. Start packing. But in 2025, Tilsawala and colleagues used fresh data from the Gaia spacecraft and Hubble to actually run the numbers properly. They identified 22 different variables and ran 100,000 Monte Carlo simulations. The result? The chance of a head-on collision is only 50% within the next 10 billion years. In half the simulated scenarios, the two galaxies fly past each other and enter a slow orbital decay through dynamical friction. They don't slam together, they just gradually spiral inward over billions of additional years. The most famous predicted collision in all of astronomy went from a certainty to a coin flip to basically, it's complicated. Now, here's the part that breaks people's brains. Andromeda has roughly 1 trillion stars, the Milky Way has up to 400 billion. That's over 1 trillion stars potentially occupying the same space, and the chance of even 2 of them colliding is essentially 0. Stars in a galaxy are like 3 grains of sand spread across an entire continent. You could pass 2 galaxies through each other and nothing would touch. What would eventually converge are the 2 supermassive black holes at each galaxy's center. Through dynamical friction, they'd sink toward the core of the merged system, slingshotting surrounding stars into higher orbits as they go. The end product would likely be a giant elliptical galaxy nicknamed Milkometa, or Milkdromeda, if you prefer the funnier version. So our galaxy's ultimate fate is either a dramatic head-on merger, a slow gravitational waltz, or 2 cosmic ships passing in the night. Which is, not the definitive answer anyone wanted, but if you think individual galaxy collisions are impressive, wait until you see what happens when entire clusters of galaxies smash into each other. The bullet cluster. Everything we've covered so far involves 2 galaxies colliding, maybe 3 if you count a straggler getting pulled in. The bullet cluster is not that. The bullet cluster is 2 entire galaxy clusters, each containing hundreds of galaxies, wado slamming into each other about 3.7 billion light-years away. It is one of the most energetic events observed in the universe since the Big Bang. Let that sit for a second. Approximately 150 million years ago, the smaller subcluster plowed straight through the main cluster at roughly 10 million kilometers per hour. The impact created a bow-shaped shockwave in gas heated to around 100 million Kelvin. For reference, the core of the sun is about 15 million Kelvin. So we're talking temperatures that make the inside of a star look like a lukewarm bath. But here's where it gets genuinely profound. During the collision, the 3 major components of each cluster separated like ingredients in a centrifuge. The stars, being so ridiculously far apart from each other, passed through largely unaffected, just vibing. The hot gas interacted electromagnetically and slowed dramatically, pooling in the center. Chandra X-ray observations show it as pink clumps sitting right in the middle. And then there's dark matter. It passed straight through everything, completely collisionless, as if nothing happened. Here's the kicker. When astronomers used gravitational lensing to map where the actual mass was concentrated, they found 2 massive clumps centered on the galaxies, not on the hot gas where most of the normal matter sits. The gravity was in one place. The visible matter was in another. That separation should be impossible if ordinary matter is all there is. Alternative gravity theories like Maundid predicted the gravitational pull should follow the gas. It didn't. Not even close. The bullet cluster effectively killed purely baryonic explanations in a single observation. A collision between 2 galaxy clusters accidentally told us what roughly 27% of the universe's total energy content is made of. Something we cannot see, cannot touch, and cannot detect directly. But it's there. And we know because 2 of the largest structures in the cosmos crashed into each other, and the universe showed its hand. If you enjoyed this video and want to see more, click the video on the screen now.